Hi guys, in this video we will be solving spread of infection problem. So the problem says that we will be given a graph. Let's suppose this is my graph. 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is my graph. Okay. And there is a source node which got infected at time t is equal to 1. Okay. And we have given a final time. Let's suppose t dash is my final time. So this guy has infection, that is source node has the infection, and in 1 unit of time the infection spreads to all the neighbors of the source node. Okay, so we have to tell that till the t dash time elapse how many guys are infected. Okay, let's suppose that for now t dash is equal to 2, or let's suppose t dash is equal to 3. Till time is equal to 3, how many guys are infected? Okay, so at time t is equal to 1, source node is infected. Okay, at 1 unit of time how many guys will be infected? All the neighbors will be infected. So at time t equal to 2, these 4 guys will be infected. Okay, now at time t equal to 3, all the neighbors of these guys will be infected. Time t equal to 3, these guys will be infected. Okay, now suppose there are some more nodes. Okay, so we have to tell how many guys are infected till time t is equal to 3. Okay, so these guys will be infected at what time? At time t is equal to 4. But 4 is greater than t. So these are not the part of our answer. So only these nodes are part of our answer. These many guys are infected at time t is equal to 3. Okay, so we have to tell how many guys are infected at a given time. Okay, so this is pretty straightforward BFS, like it is a modified version of BFS. So what we can do is that we will start from our source node at time t equals to 1, and we will traverse the graph in a BFS fashion, and all the neighbors will get infected at time equal to our current time, whatever the time at which we are infected, plus 1. So if we are infected at time t equal to 1, so our neighbors will be infected at 1 plus 1 equal to 2. So these will be infected at time equal to 2. So we will traverse the BFS till the current time is less than the t dash time. Okay, we will traverse the BFS and we will count that how many nodes are infected. Okay, so this is what we have to do in this problem. So now let's move on to the coding part. I will give you explanation while coding also. Okay, so we have to tell how many guys are visited. So we will need a visited array to mark which guys are already visited. Okay, why we need this? Because why we need this? Suppose this is node 1, node 2, node 3, node 4. Okay, this guy is visited at time t equal to 1. So all these guys will get infected at time t equal to 2. Okay, now the neighbor of 2 is also 1. Okay, so according to 2, 1 will be infected at what time t is equal to 3. But one is already infected at time t is equal to 1, so it will not get infected again. Okay, so once it is infected, then it means it is infected. Okay, it is not like that it will again get infected at a different time. Okay, so we have been given a source node from where we have to start. So it is the modified version of BFS, so I am writing the function name as BFS only. Let's suppose it will return me the count BFS. So I have to simply print the count, how many persons got infected at time t equal to t dash. So I will pass a graph, I will pass the source node, I will pass the visited array, and I will pass the time. Okay, so we will have to make a class also to solve this problem. Why do we need a class? Because each node stores an information, like at what time this particular node got infected. Okay, 5, 6, and 7. If this got infected, then these neighbors will be at current time plus 1. So current time is what? Current time is 1. So neighbors will get infected at current time plus 1, which is equal to 2. So these nodes got infected at time t equal to 2. For the neighbors of these nodes, they will get, now the current time is what? Current time equal to 2. So these nodes 5, 6 and 7 will get infected at current time plus 1. So 2 plus 1 equal to 3. So these will get infected at time t equal to 3. So for each node we want to store an information, that is the time at which they got infected. So for that we need a class. Okay, let's implement that. Yeah, static class pair, we node and node, and we need time. So okay, we have made the class object. Now let's write the BFS function. We have to return an integer value. So return type is integer. We have a graph. Okay, integer source. What? Then we have an boolean array visited. Then what do we have? We have a time. Okay, now let's make a queue. That is what we need for BFS. Queue of pair queue. Okay, now we have to add source node, and source node got infected at time t equal to 1. Okay, now while the size of queue is greater than 0, or while the queue is not empty, what we will do, we will remove the element from the queue. Okay, and if the time at which this node got visited is greater than the time which is allowed to us, then this will not be counted in our answer, so we can simply break from here. We also need a counter variable to count how many guys got infected. Okay, otherwise what we will do, we'll check if this guy was already infected at some earlier time, so no need to count this guy again. Okay, so if this guy is visited of remove.node, that if it is infected earlier, then simply keep this guy. Otherwise what to do, we mark this guy as visited. Okay, then increase the counter for this guy, then add its neighbors at time greater than 1 unit for the current time, then the time for this guy. So what we will do, for edge edg in graph of, that is this removed element. Okay, if it's visited, if its neighbor is not with infected, then we can add this its neighbor. First we need, sorry, we can simply add new pair of neighbor, and the time will be my current time plus 1, that is remove dot time plus of 1. Okay, when this is done, we can simply return the count. Okay, now let's check we have written everything or not. Okay, we have removed, you greater then break. Otherwise if visited already infected, then continue. Otherwise mark it at visited, increase the count. Okay, if it is not visited, means not infected, then add this guy, finally return the count. Okay, pair class is okay, so we have made the boolean. Okay, we have called for answer, this is also okay, finally printing the answer. Okay, now let's try to run this code and let's see whether we have written correct or not. Okay, whether our solution is correct. Okay, so there is some cannot find symbol. Okay, so I have written PA in small caps somewhere in line number 54. So here P will be capital. Okay, let's check is there any more error. No. Now let's try to run it again. We are getting correct answer. Let's try to submit it. Let's see whether we are passing all test cases. Yes, we are. So our solution is correct. I hope you guys would have enjoyed the video.